Let's see how the random method of math object works and how we can also make an OTP generation function out of it. We'll also see what are the variations available with random functions, what are the more arithmetics we need to perform to generate an actual OTP. So let's see with a quick example. So firstly, we'll try to understand what exactly the random method is. So random method is a static method provided by the math object to us, which will provide a number from equal to 0 or maybe greater than 0 up to 1 as a floating point. So it can also give us 0.0001, 0.012 something, a floating number. So let's try to understand with this syntax. So this is mat.random. So it will us provide a number between 0 and 1 as a floating point. So this is the number I'm getting. And if I just keep refreshing it, you can just see every time I'm getting a different number. So why not we can make use of this by performing some more arithmetics to generate a OTP. So in this case, you can understand there is a requirement to generate a 4-digit OTP. So in which the requirement is the minimum number of OTP should be 100 and the maximum should be 9999. So if we try to do with mat.random function, how it works. In a first scenario, I'll try with the least possibility what my math.random can do. Let's say, for example, math.round is producing 0.000001 like this. So which is I'm considering minimum possibility, the minimum number math.random function can generate. So if I just multiply that with double line, which is a maximum, so I'll get 0.000999 something a number, which I do a round off, then I'll getting a 0. So here itself, I'm failing to satisfy the condition. I need minimum 1000. Let's also try with maximum number that a math.random can produce. In that case, what happens? So let's say 0.999 like this, a number being generated by math.random function. So again, we'll apply a multiplication with our maximum number. So we are getting 9998.999. And if I do a round off, I'm getting a perfect number 9999, which is equals to the maximum number. But we are failing at a condition of this 0. It should not be a 0 when we are going with a minimum possibility. So it should come to the 1001. So this scenario fails with us. So we need some additional logic. What we can do now, in this case, instead of multiplying with 9999, which is a maximum number, what we will do, we'll do maximum minus minimum, which is 8999. So we'll do the multiplication with 8999 to our minimum possible number generated by math.random. So we are getting here 0.0008 something, which is almost equal to a 0. And in that, we will be adding our minimum number, that is 1000. And that's what we are satisfying with a minimum condition of receiving an OTP of 1000. Let's try with the maximum possibility where our math.random function can generate. So this is the maximum number our math.random can generate, for example. So again, the same multiplication with 8999. Outcome will be something like this. If I do a round figure of it, it will be 9999. And in that, if I'm adding 1000, which is a minimum number again, I'm getting a very perfect number, 9999, which satisfied our condition of our algorithm. So this is how we can generate an OTP where we can also specify what should be the minimum number of OTP should come and what should be the maximum. So between these two numbers only, you will be generating an OTP. Let's try to generate this with an example. We'll create a function here. We'll say get OTP, and the parameter here will be the minimum number and the maximum number as per your choice. And here I'll just start the arithmetics here. Firstly, I'll just take out a random number. So it will be math dot random. Okay. So this is my random number. Let's confirm it step by step. I'll just keep doing a log, or maybe let's say a variable will be using that will be more appropriate. Let's call with a minimum of 1000 and maximum of 9999. Of course, we are not making use of that. I just want to make sure how the math.random is generating the different numbers. So we are getting a different number 0.77, 46, 45, 96. So all the floating point number between 0 and the 1. And this is what the first number we are needing. After that, I need to multiply this with maximum minus minimum. It means 8999. So I need to multiply this with 8999, for example, which is equals to our max minus mean. And I need to specify brackets here. Why it is important? Because the precedence of into operator is more than the minus. So if I won't do this, what will happen? Firstly, the multiplication will happen and then it will perform the minus, which is not a correct scenario. So we have to explicitly mention this. Now let's see, if I perform this multiplication, I'm getting a perfect numbers like this 0.00 something or 8998.999. This is a maximum possibility. So we are getting 7689. That is also good between like a 4-digit number. This is also good. This is also good. I'm trying to figure out a number which comes below 1000 because in that case it will not be a 4-digit number. So we should be getting it. This is almost near. At least one number we should be getting. Let me try a few more clicks. Yes. So here we are getting 703.64, which is not satisfying our condition because our condition says that we should get a minimum 1000 number. So again, the next operation comes into picture. We have to add plus 1000, which is a minimum number in each OTP. So and let's say plus 1000 here, which is a minimum number for us. That's perfect. Let's generate now. Now there is no possibility that I'll get below 1000. I'll compulsory get the above 1000 only and the below 9999. So this is how it works. Now the only problem is with this fractional number. So to remove that, the complete part I can say math dot round. Okay, let's see the final outcome. So we are getting 4660 and all these. So these are the perfect numbers that we were expecting. Now, if you want to generate the possibilities of minimum and maximum, so out of this random, you can manually try to say 0.00001. So this is a minimum possibility the random function can generate. So in that case, you are getting 1000. That is what the requirement. And the maximum possibilities, for example, 0.99999 like this. In that case, you should be getting 9999. This is what we are getting. Let's make it as it is like previous and confirm the OTP is good. Now you can just change this condition. Let's say I want a 6-digit number. So let's make it like this. Okay, so the minimum number is 100000 and this is 99999. Let's see the outcome. We are getting a perfect 6-digit OTP always, in which I'll not get any zero as a prefix. You might be observing in some OTPs there will be zero in front of. Of course, we can do that. If I just start this number starting from 0, I can get that. Let's see. So we just need to explicitly pad zeros for that we can write additional logic for that. Let me just figure out if I get anything below. Yes, I'm getting, this is a 5-digit number. It means at the start there we can append a 0. So of course we can do that by padding left or something additional zeros. But in this case, we'll proceed with 4-digit OTP only. So this is how the random function works and give us a random number between 0 and 1, and that we can apply a more mathematics on that and get a very perfect OTP for our requirement.